Today we're here for Concord Design, and we're going to demonstrate our end-to-end development framework for manufacturing. And we're going to demonstrate that with a robot we built, which is a two-dimensional generative art robot. And today we're joined by our mechanical engineer, Francesco, and our construction engineer, Johan. Francesco and me, we're joining you from Canada, and Johan is joining us from Sweden today. So we are I will demonstrate running the software on my side, and we're going to control the software over an SSH tunnel, and the robot will be moving in Sweden. So it's a funny detail what we're doing. Okay, I'm going to share my screen now and demonstrate the software part of the platform. So on the right-hand side, we have an application written fully in JavaScript, and I'm just running it locally right now. And then I've just opened DevTools, and I'll do all the coding using Chrome DevTools, which is the window on the left. Before I start doing the real examples, let's take a look at Johan, and maybe he can demonstrate a little bit what the robot is doing and what components are in there.
Yes, of course. And I'm going to switch to robot mode. Yeah. So here you can see the robot. In this case, it's a plotter. It has two stepper motors and a servo for pen up and down. The motors are controlled by TMC 2209 chips that is connected to a V3 shield. The shield is then connected to the ESP32, which has the capability for internet connection. So the communication is by the ESP32.
Very cool. So to clarify, we are actually talking to the ESP32. It's running a piece of C code that opens up a WebSocket connection. So it's actually a server, and the software here is actually a WebSocket client, which is sending movement commands to the motion controller. So let me demonstrate how the code looks. So you don't have to look so hard at this initial code, because it's kind of the same every time. It will come in a template when you want to do your coding. The only thing you want to look at is simulation mode, true or false. So if I activate simulation mode, I'm actually not running any real commands towards the motion controller. So that's usually where you want to start, simulation mode true, and you want to make sure that it's drawing within the bounds of the robot. So let's try this now. It's very simple. I'm trying to draw a triangle. I use enable code tool to move the pen down. So first I'll have a movement with the pen up. Then I'll enable the pen, and then I'm going to draw out, this is 0 to 200, the grid in X and Y. So what I'm going to do is I'm going to draw 120, 70, 160, 120, and back to 50, 70, where I moved here in the beginning. And then I'm just going to tell the robot to move these coordinates, okay? So let me try and run this. So I'll run this, and I press this input button. And here you can see that there is a black line which symbolizes that the pen is up, and then this red line symbolizes that the pen is down. So I'm now going to switch from enable from the simulation mode true to false, and we're going to be able to see it doing the operations on the robot. So put the robot in focus now. Very cool. So now let's turn into sharp mode, and I'm going to set this simulation mode to false here. Of course, I've done that already. And now I'm going to run the code. So now we're going to see the robot moving for real. And of course, I have to activate it by pressing input here to run the code.
Fantastic.
And as you can see, the triangle is being drawn just as it was simulated here on my side virtually. So we're basically simulating the motion controller command. In the case where we have many points, you see how I do here, one by one, I'm adding these positions. If I want to, I can simply send them all in one command. So let me illustrate that it's the exact same thing. So what I'm going to do here is simply comment out this code. And then I'm going to comment the one where I send all the corners of the triangle in a single command. And then I press input to run the code. And as you can see, it will be the exact same triangle. So this is what we're going to use now for our circle option. In the circle option, when we want to draw a circle, it's a little more complex because, of course, all the points on a circle are many, many coordinates to define the circular motion. So what we use here, we've built this geometric modeling kernel to handle all possible geometrical shapes. So in this case, we would basically just use the circle object here, which is circle 2D, and these are ready to use. And then we can use, I've defined here to just show you how powerful this is. I have defined a scale matrix, I've defined a translation matrix, and I can multiply matrices, and I can actually just transform the circle based on translation is moving the circle, and scale is, of course, scaling the circle up or down. And then what I'll do is I'll just basically use this map, positions and parameter that breaks down the circle. And what you'll decide here is how many samples do you need? And in this case, I'm using 32 samples. So now we're running the circle command with the 32 samples. So the number of sample is going to decide how smooth the circle is. So if we do more samples, execution time will increase a little bit, but not very much. And as you can see, even with 32 samples, it's a pretty smooth circle. Now I think it would be good for the next example to change the paper route. Do you think we can change the paper route?
Yes, no problem.
As I said, in this example, we're going to use the circle code again. But instead, we're going to draw several circles. And here I've defined a grid where the circle should be. So let me first illustrate how we can use the simulation mode. Let's say we have circles and we want to draw them using, let's say we have a cutter or something like that. Maybe we want some material. So then we can calibrate here, draw the circles. And as you can see, for a cutter, quite a lot of material would be lost here in between the circles. So of course we can calibrate this and make sure that it's exactly how we want it using the simulation mode. And here you can see, here we're not using any material. We're just having the circles exactly perfectly touching. So now let me turn off simulation mode and let's control the robot. So let me run this code. And of course, it's going to be a little slower now. So we're probably going to fast forward through this part of the video. So now we have replaced the paper for our final example. And this is more like the real thing that we imagine this robot will be used for. And in this case, we use, I think it's Sierpinski's triangle. It's a triangle fractal. So it has a much more calculation, but remember, this is just simple JavaScript. So there are plenty of examples out there that you can reuse. And of course, you can even use ChatGPT to generate these. What I'm going to do now is basically run a more complex structure. But in the meantime, first, I'm just going to emulate it. So I'm just going to look for the simulation mode first. So what I'm going to do now, I'm going to start by simulating this one and make sure that it's doing the right thing. And as you can see, there are some black lines here as well. And the reason is that I'm calculating and lifting the pen between the different groups of triangles. So I have a minimum distance where I will lift the pen. So what we're going to do now is we're going to try and see if the robot can draw this thing. So I'll set simulation mode to false, and I'll run the code. And of course, it's going to be a little slower now, so we're probably going to fast forward through this part of the video. So that concludes today's demonstration. So just to repeat here, we've built a piece of software that you can program with JavaScript to generate art. And our system is an end-to-end system. It's a piece of software running as a client that you run on your laptop. And then there is a motion controller that we also built from scratch. So it's basically a motion controller that we've programmed that is connected in an end-to-end way to our software. And in this initial prototype, it can do simple art projects, draw simple figures. But of course, this can be generalized from we built now and completed our geometric modeling kernel in 2 dimensions, but this can be generalized to 3 dimensions, to CNC machines. And right now, we have this for art, and it's a really fun toy to play around with. So I hope you enjoyed this demo, and thank you.
Thank you.